Flack math! Give me some math and I'll give you some flack. Flack math!
So we're going to talk about the law of sines, and I'm going to explain it to you, but if you don't follow me at all, it's not the end of the world. It's just a formula you have to memorize. And really, even if you do understand me, then it's better just to memorize the formula, which when I say memorize, I mean make sure it's in your notes so you can use it on the test. Okay? All right, so this is lesson 71. We're going to talk about the law of sines. Okay, so let's just get a triangle up here. We'll call it ABC. And then we're going to label our sides. And the way we label our sides is the opposite of angle A is lowercase a. The opposite of angle B is lowercase b. And the opposite of angle C is lowercase c. Okay? So far, so good? All right, so you guys remember this? What's the sine of A? What's the sine of A? Well, you don't know because that's not a right triangle. But if I drew a line here, if I drew the height of the triangle, we'll call that H, which is kind of confusing because that's not a hypotenuse, okay? But we are, we're gonna, so in this case, what's the sine of A?
H over C.
H over C, right? Opposite over hypotenuse, right? Good, good. So what would the sine of C be?
B over A.
So it would be opposite of our hypotenuse, so it would be H over A. Sine of C would be. Sine of B, we don't know because that's in a different triangle, okay? But for now, just look at sine of A equals H over C, okay? So to find the area, it's 1/2 base times height, right? Well, in this case, B is the base and H is the height. So what's the height? If I multiply both sides by C, the height equals C times the sine of A, right? You see how I just solved for H in this case? Here, let me write it in a different color here. Right, so H equals C times the sine of A, right? Now this is going to lead somewhere, so don't worry. So how do you find the area of this triangle? Well, it's 1/2 base times the height, which is C times the sine of A. Now, why is this helpful? Is now you can find the area of a triangle if you're just basically if you're not given the height and you're just given a couple sides and maybe an angle, then you can find the area of that triangle. So area, now again, it's okay if you don't understand how I got to this formula, even though we kind of explained it here. All we did was substitute this in for H, 1/2 B H, okay? So it's weird because normally you don't, it's kind of like the classic pre-out of like math 7 mistake, is if you're trying to find the area of a triangle, it's not 6 times 7 divided by 2, right? It's base times height divided by 2. But now we can do this where if we're given this angle here, if we're given this angle, like let's say that's 61 degrees, I can find the area of that triangle, even though I don't know the height, okay? So it's just 1/2 B, so 3 times 7 times whatever the sine of 61 is, which is a constant number on your calculator. You can figure that out. Okay? Now, this leads us to the law of sines. The law of sines says the sine of A that these ratios are the same. Okay? Sine of A is to A as sine of B is to B as the sine of C is to C. Okay? So now this is helpful because based on what you're given, you can plug whatever you have into this to figure out anything you want. Okay? So let's just put this into action with example 2. First of all, write this down. Okay? And if you want to do it, we can do an example if you want. I'll just write it out. We don't have to actually do the work. But this is example 1. Example 1 looks like this. It's a triangle. Here's A, B, C. Okay, this is 55 inches. This is 24 inches. And then we're given this angle, which is 115 degrees. Okay? So basically, you can use this area if you're given an angle and its surrounding sides. Okay? So instead of sine of A, we're going to say sine of B. And instead of B and C, we're going to use these guys. Okay? So basically, to find the area this way, if you're given an angle and the surrounding sides, then area equals 1/2 24 times 55 times the sine of B. That's all you do. Okay? So that's 12 times 55 times the sine of B. And that gives you, I'll just give you the answer here, about 598.2 square inches. Okay, that's it. So you can use the sine, even though this is not a right triangle. That's what's weird about this, is I thought trigonometry only applied to right triangles. Well, theoretically it does, because you are forming a right triangle right here to calculate the height. So that would make this the base and then this the height. So technically it is still working with right triangles, but you can use the sine of B, whatever that is. You can find the area using trigonometry, even though that's not a right triangle. Okay? So that's the formula. Make sure you write that down. The other way to think about this is like this, or area equals 1/2 AC times the sine of B, or A equals 1/2 AB times the sine of C. So all three of these are the same thing, and they're not always going to give you, like, they're not going to say A, B, and C here. They're just going to give you a triangle and ask you to use the law of sines, well, not the law of sines, but use that formula to find the area, okay? So all three of those area formulas are the same, and A, B, and C are relative to whatever you want to label them.
I don't like that B also means base and A also means area.
Yeah, it is confusing. And we probably shouldn't have used those letters because that makes it confusing. But all right. Area. Let's just spell out area. Okay, so the law of sines. This is what we got. Keep looking at the wrong book. So I'm going to do example 2 here. Here's what example 2 says. Find B, round to the nearest tenth. Okay, so here's a triangle. And I'm going to call this 4. I'm going to say that's B. That's what we're trying to find. So this would be angle B because lowercase b is opposite uppercase b. Okay, so if I wanted to label that, I could, but I'm not given that. So I'm just going to say C, but our only objective is to find B. All right, now I need a little bit more information. I've got some angles, 48 and 35. Okay, so this time I'm given 2 angles, which is nice. I could figure out that third angle if I wanted to. What is that? 97 degrees, but I don't need to. Okay, so what I'm going to do is I'm going to plug in what I know into this mess. Okay, so do I know the sine of A? Yeah, I can figure that out. Sine of A is sine of 48 degrees, so I figure that on the calculator. Do I know what A is? Yeah. Remember, A is opposite angle A. Little a is opposite angle A, so that's over 4 equals, well, do I know the sine of B? Yep, because I know B. So sine of B is going to be sine of 35 degrees. Over the opposite side of B is B. So now I've just got the fish method. So now I just figure that out. What's the sine of B? We'll plug that into your calculator, multiply by 4, divide by whatever the sine of 48 is, and that'll give you B. And that is approximately 3.1. Okay, this is the law of sines. That's nice. And this is pretty easy to remember, right? Sine of A, or sine of an angle over the opposite side of that angle is equal to sine of another angle, doesn't matter which one, over the opposite side of that angle. Now, you would probably never use all 3 of these at the same time, but this is just because this is a triangle, right? So it's just giving you all 3 options just in case. Okay. I swear I remember making a video about this, but apparently I didn't, because I started with 75. Oh well.
Almost there.
I'm almost there. Oops. I'll just leave that up there for a second. Okay. Okay. So now we're going to talk about ASS. This is why this never worked. So SSA. So you remember the theorems that prove that triangles are congruent? SSS. SAS, ASA, AAS, but we could never quite get to that fun acronym ASS because it never worked. Because if you had ASS, then it could look like this. So remember that SSS means if you can prove that all the sides are congruent in one triangle to all the sides in another triangle, then these are congruent. That's SSS, right? SAS is if you can prove that one of the sides and its included angle are congruent to one of the sides and its included angle in another triangle, then that's SAS. That works. Do you remember doing that in geometry? You wouldn't know yet, Audrey, but and then ASA works. So if you have two angles and the side in between, if you can prove that, then those are congruent. So this is why ASS doesn't work. Okay? I remember when I was like, oh my gosh, the math teacher is going to write ASS on the board. It's only a matter of time. Look it. It's just one more. But ASS doesn't work. Yes, and I'm going to put that on the board. Now it's on the internet. Don't be embarrassed. Okay, ASS doesn't work. Here's why. Because if I had this triangle, and let's say that this side was congruent to this side. Okay, bear with me here. But see, this is the same as that. So see how this doesn't work? Because that is still the same there, right? And this angle is still the same. But it doesn't work because this side flips that way and you don't care about that. So this doesn't work. These are not congruent triangles. Okay? So it only works if that angle is an obtuse angle or it's a right angle. Okay? Now it could work, but you don't know. You can't assume that. Okay? All right. I keep looking at the wrong book. So that's why that ASS doesn't work. Now they say SSA in the book, but I think it's easier to remember if you do this because we already feel guilty about writing that on the board, right? So you should feel guilty about using that as one of your congruent triangle proofs. Okay. All right. So let's say given A, if H equals sine of A. So in this case, this is H and this is H. They both have the same H's, right? Okay. If H equals C times the sine of A, that's what we talked about later. So if this was A, right, this is A, B, and C. So we'll say prime and prime just because it's two different triangles. Okay, so H equals sine of A. The sum of the measures of angle A in each triangle is 180 degrees. Okay, so yeah, so obviously that doesn't work because here's C, so they're going to equal two different things. Okay. But that would still equal. So that it could be two different triangles. So that's why that doesn't work. All right. Let's move on from that because that's probably not going to be too terribly useful. Okay. So let's go backwards. Not backwards, but let's try to find, using the law of sines, instead of finding a missing side, let's find a missing angle. We can do that. So here is example 3. Let's call this ABC 3563. We'll call this 57 degrees. And I want to find angle B. Let's find the measure of angle B. So what's the law of sines?
Sine of A over A equals
Sine of 57 over 63
Equals
equals
sine of b over.
All right, so guys, same thing, right? So you're just going to fish method this, and then instead of giving you b, it's going to give you the sine of b, right? So you can solve for the sine of b, and the sine of b is going to be whatever the sine of 57 times 35 and then divided by 63 is, right? So if you fish that out, that's not going to give you b. It's going to give you the sine of b, okay? So sine of b is going to be 35 times 57, sine of 57 divided by 63. The book doesn't give me that, so what is that?
0.43.
0.43-ish? Okay, now how do you find b now?
What's the opposite sign?
Yeah, so inverse.
Inverse sign.
Yeah. So now we find the inverse of each side, right? From blip, blip. So basically the inverse sine of 0.43, which is?
28.5.
Yep. So now, did you say 0.43 or did you actually take the sine of b? Did you actually take whatever that is, which isn't 0.43, that was a rounding, right?
Right.
So what the book said is basically 27.8, okay? So you're off by a little only because you took the inverse sine of 0.3. Don't take the inverse sine of 0.3, take the inverse sine of sine of 57 times 35 divided by 63.
Okay.
That will give you a more exact answer, which is 27.8-ish. More exact than the other. It's closer. Okay? Okay, now, here's the deal. Example 4 looks like this. It just says that, let's say that measure of angle A equals 14 degrees. A equals 20 and B equals 25. Find measure of angle B. Okay, so let's try to draw this. So the side opposite of angle A is 20. So let's say this is angle A, and it's 14 degrees, so it's pretty small. So let's say this is 20 here. Okay, and then B, which I'm going to put B over here. This is 25. I want to find the measure of angle B. Okay. Now here's the deal. This is not the only way to draw this triangle. You could draw it like this. You could still do that 25 there, and then you could do a 20 here, and then there's B. So there's two different triangles you could draw. If you're just given that information and not a diagram, there's two different triangles. Okay, now here's how you determine that without having to draw it. You determine that because basically, hold on one second. Okay, so here's why you have to do this, because the opposite side of the given angle is less than the other side. Okay, so if the opposite side, so basically if the opposite side is less than the other side, the opposite side of the given angle is less than the third side or the second side, then there could be two possible answers. Okay, so basically, let's think of an easier way to say that. Such a triangle. Okay. Hey, Avery, your whispering isn't as quiet as you think it is.
That wasn't me.
Oh. All right.
Good job, Gracie. Sorry.
My grandma used to struggle with that, like in church. She would say embarrassing things, like you just did.
Oh, I don't.
They didn't record church though.
They didn't record. I mean that, and here's the deal. There's like a plug-in in Zoom that if Zoom doesn't hear anything, it turns up the volume. So if there's silence and you say something like that, then now the world knows. Okay, so please treat Gmo nicely for the next week or so. Okay.
If it helps, it was about me, and I just don't.
Okay.
Thanks, Gracie. You're welcome.
All right. So here's the deal. There's two possible answers. So you have to kind of go through that. Now, the shortcut to determine that is the angle opposite of this side. The given angle 63 is more than the other side. Okay, so since 63 is greater than 35, then there's only one triangle. Okay, but since 20 is less than 25, then two possible triangles. Okay. So you just have to determine both options. So it could be that this really obtuse angle, or it could be this another acute angle. Okay. But once you get down to the inverse sign,
I only got one answer out of that.
and you got, what did you get?
17.6 degrees.
Okay. So it could be 17.6 or it could be 180 minus 17.6.
Oh, okay.
Okay. So it's kind of annoying, but you just have to determine whether this is the case. So here's the kicker. Oh, well, I meant to say since, but I'm so used to writing sign that I just dropped the, okay. All right, so let's move on. Good job. Moving on to lesson 72. Okay, so now we're going to start talking about the properties of logarithms. Okay, so this is a new concept. So don't stress about this because we're just going to give you little chunks at a time about logarithms. So far, I think I've only graded one of your tests, but you know how to write an exponential expression as a logarithmic expression. It's just rearranging it a little bit. So now we're going to learn some properties of logarithms. So a little bit of review. Remember, if y equals b to the x, then log base b of y equals x. Okay? So basically that little base, that's the base of the exponential expression. this is the answer, or the power, the answer to the exponential expression goes there, and the exponent is the answer to the logarithmic question. I'm gonna flip this over so I quit looking at it. That's my geometry book. That's what's next. Okay. Okay, so since a logarithm is the exponent applied to a base to obtain the given value, b to the x equals a is equivalent to the log base b of a equals x. So the definition of a logarithm can be used to find the inverse of an exponential function. Okay, remember, to find the inverse, we just replace the x's and the y's, right? So if I say this is x equals b to the y, now I need to solve for y. Okay, remember that exponent is the answer to a logarithmic thing. So how do I rewrite this in logarithmic form? Log base b of x equals y. Okay, so this is the inverse of this. So, which it kind of makes sense, because look, we're just replacing the x and y. Okay? So the way that looks on a graph, so if this was y equals b to the x, then this is what the inverse looks like. Oh, that was drawn bad, but kind of get the idea, because this is the line of reflection. Whenever you have an inverse, that y equals x, which makes sense because you're just swapping the y and the x. So it's going to mirror across that y equals x line. Okay, so this is x equals b to the y, or yeah, y equals log base b of x. X equals log base b of y. Okay, so here's the inverse properties of logarithms. Can't read. So b to the log base b of x equals x. And log base b I can't read it. Of b to the x equals x. Okay. So basically, the exponent of this base would have to be x. So log base b, in order to get basically back to x. Okay. So write those down. These are a lot easier to just remember or to refer to in your notes than to explain. Okay. Okay, so here's some examples that you might see in your homework. Here's example 1. Simplify. Log base 5 of 5 to the 2x plus 3. Okay, well, that looks confusing. So what do? So we need to find the answer to this. And it's a lot easier than it looks. So basically, remember logarithms are what exponent do you apply to b to get y, to get this? What exponent do you apply to this to get this? Well, what exponent do you apply to this to get this?
Oh, 2x plus 3.
Just 2x plus 3. And that's one of these inverse functions is right here. Look. This looks exactly like this second one here. Log base b of whatever that is to the x is just that exponent. So that's all that is. Okay. All right, let's try 1b. Log 2 to the log base something. My gosh, can anyone read that small? It's ridiculous. I feel really old. 2 to the log base 2 of p. Okay, what's that equal? Well, you could look at the inverse function pretty easily.
Yeah, that would be like so missing.
So I'm trying to find what this equals, right? So 2 to this exponent. Well, this exponent is what do you apply to 2 to get p? Well, so that would be basically whatever that is. So 2 to the, so what's the answer to this? Look up here.
Isn't it just P?
Yeah, it's just p. Okay,
Okay.
that's it. Because think about it. This is the exponent of this. So this is 2 to the p. No, this is the exponent of. No.
Yeah, so it's
Yeah. So you're kind of like trying to figure out what the answer to the exponential expression is would be p, right? Because this is the answer to the exponential expression. Well, this is the base, and this is the exponent, and this is the answer. Okay? So again, now you can find your way through it logically to figure out why that makes sense. But just write these down and refer to these inverse properties. Okay? Now, we're not going to try to trick you. We're not going to say like 2 log base 3 of p or whatever. Okay, so look at these, and then you just kind of have to look at your list of all your logarithm properties and figure out how to simplify it. Okay, so far you only have 2. The 2 inverse properties of logarithms are these. Okay, so if you're given something weird that looks kind of like this, look at that, and that'll give you your answer. Okay. All right, next part. I'm going to do this next formula is the change of base formula. Okay. So write this one down too. Change of base formula. What the heck does that mean? Here's what it means. So most calculators calculate logarithms only in base 10. So if you just see log with no little number there, then you can assume that it's just base 10. Okay? So LOG on your calculator is just log base 10. Okay? So one way a logarithm with a base other than 10, or e, which is what we'll talk about, which is the natural log. E can be evaluated by applying the change of base formula. So for any a greater than 0 and a not equal to 1, any base b, we'll call it b, such that b is greater than 0 and b is not equal to 1, log base b of x equals log base a of x divided by log base a of b. Okay. So if you want to change a logarithm, the base, like base a, all you have to do is this formula, okay? So if it's log base 10, then you would just plug that in for 10. And then I'll just give you an example, okay? So I want to evaluate a logarithm by changing the base. So I want to say log base 4 of 8. So basically, if I think about this exponentially, I'm asking myself, what exponent do you apply to 4 to get 8? Well, nothing, right? 4 squared is 16. 4 to the first power is 4. So it's somewhere between 1 and 2, right? Now, your calculator doesn't do that exponentially. So you have to use logarithms. So this is going to be, we're going to apply to this formula. So we're going to say, log base 4 of 8 is just log of 10, or this is log base 10. So you just say log of 8 over log of 4. Okay, on your calculator, remember log without any base is just 10. So on a calculator, this would give me the log base 4 of 8, okay? By taking the log base 10 of 8 divided by the log base 10 of 4. Okay, so on your calculator, there's not a nice little button that does that. So you have to take a log of that over log of that, okay? And it works. This is confusing, but this makes sense, okay? So just, if you're gonna write something down, write that down. And call it the change of base formula. Because the whole A's and B's and whatever is confusing, okay? So then you end up getting approximately 0.903 divided by 0.602, which is approximately 1.5. Okay, which kind of makes sense. 4 to the 1.5 power, which actually doesn't make perfect sense. It's not approximately 1.5. What exponent do you apply to 4 to get 8? 3/2. Because 4 to the 3/2 is 4 to the third, which is 64, square rooted, which is 8. So it's exactly 1.5. Okay. All right, now let's explore this a little bit. You guys got this inverse property of logs, change of base formula? Okay. Now on a test, on your test, you're probably going to be given these formulas and these nice things, but again, it may not be totally helpful if you're given A's and B's and stuff like that. Okay, well, let's just do this. So here's the deal. Here's another property. Log base 2 of 32. Log base 2 of 32, can be written like this, log base 2 of like 4 times 8, right? All I did was take 32 and factored it into 4 times 8. Okay, so if I did, well, first of all, do you know what the answer to this is? Log base 2 of 32. Remember the question you asked? What exponent do you apply to 2 to get 32? What is it?
3.
5. Right? Because 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2 is 32. So let's see what log base 2 of 4 is. And then let's see what log base 2 of 8 is. So this is 5. I just want to see what I get. What's log base 2 of 4? 2, right? What exponent do you apply to 2 to get 4? 2. And what's the exponent here? 3. So how do you get 5 from 2 and 3? You add them. So here's the deal. When you have log base 2 of a product, it's just log base whatever of A plus log base whatever of B. Now it doesn't have to be 2. It can be anything. Okay? So it becomes an addition problem, which kind of makes sense because remember those properties of exponents when you have multiplying exponential expressions, what do you do with the exponents? You add them. Okay, so it kind of makes sense where you would add these logarithms when you're dealing with multiplication. Okay.
All one lesson.
Yeah. It's logarithms. It's a new concept. So it's, all right, guys, basically I want you to write down 3 more things. So this is one of them, product property of logs is basically log base B, so of mn equals log base B of m plus log base B of n. Now here's what they have to say. M and n have to be positive and B can't be 1. So M, N, and B are positive and B cannot equal 1 because 1 to any power is just going to be 1, right? So the most important thing is this. If you don't write that down, if you don't remember that, if that doesn't make sense, that's okay. Just write that down. Okay? So you can approximate the value. So if I do an example here, example 3a, I'm going to approximate log base 3 of 63. Okay? So I'm going to use this. I'm going to say, they're going to give me a hint here. Log base 3 of 7 is approximately 1.7712. Okay, well, why does that help me? How can I break down 63? What 2 factors do you want to use? What times what is 63?
9 and 7.
Okay, so I can say this, right? So I can, since I can multiply 2 numbers to get that, then I can do the log of that 1 factor plus the log of the other factor. Now I know this. Somebody besides Drew, tell me what log base 3 of 9 is. Remembering what question you have to ask. You guys know what log base 3 of 9 is?
Isn't it 3?
No,
Because 3 squared root of 3 is
3 squared is 9.
2.
So the answer would be 2. The question you ask is what exponent do you apply to 3 to get 9? 3 to the 2, 3 squared. So this is 2, and this is about 1.7712. They're going to give that to you. So it's approximately 3.7712. Okay? So if one of these factors is something that you can apply an exponent to that base to get, that's nice. That makes it easy. Okay, well, what about this? Let's do log of 6, log of 60. Okay, well, what am I missing?
Base.
Yeah, so what's the base?
10.
10. Okay, so I'm going to say log base 6 is approximately 0.7782, which is a major hint because the other factor would have to be 10. So what's log of 10 equal? You guys know? So what's the base here? 10. So what exponent do you apply to 10 to get 10? 1. So that's 1. And this is 0.7782. So it's approximately 1.7782. Okay, so far pretty easy, right? Okay, couple more things. This kind of makes sense. What do you think the quotient property of logs is?
Something to do with division.
Well, if the product property is to add the logarithms, what's the quotient property?
We subtract.
Subtract, which kind of makes sense because remember when you divide exponential expressions, what do you do with the exponents? You subtract them. So log base b of m over n equals log base b of m minus log base b of n. This is the quotient prop. Okay? Now, we have to say some things here. So we have to say that b can't be 1 again. And we technically can't say that n is 0, right? But we don't have to because m, n, and b are positive. 0 is not positive. So we can say m, n, b are positive. And b cannot equal 1 because you can't have a 1 base because you can't apply any exponent. Any exponent applied to 1 is just 1. Okay? Can you remember this? Well, if you can remember this, you should be able to remember that. Okay, well, let's do this. What's log? Here's example 4. What's log base 4 of 6? Well, now we can just think of some division problems that equal 6. Okay, but they're going to give you a hint. They're going to say log base 4 of 48 is 2.7925, approximately 2.7925. And it's also going to say log base 4 of 8 is approximately 1.5. Well, that just made it really easy. Because then you just subtract those and you're done, right? Because this is just log base 4 of 48 divided by 8 is just these two subtracted. Log base 4 of 48 minus log base 4 of 8, which is just that problem. That's easy. So 1.2925. Okay. I'm going to do 4b just because there's an e in there. So I'm going to do ln. So this, I don't know why they didn't talk about this yet, but ln is log base e. So that's how you would, instead of doing log base E or whatever, it's just natural ln. Okay. So the natural log of e to the 4th power over 3. Okay, well that's going to be natural log of e to the 4th, which kind of makes sense because we can use the inverse property, because remember, natural log is just log base e. So what exponent do you apply to e to get e to the 4th? 4. Okay, and then minus natural log of 3, right? So they're going to give you natural log of 3 is approximately 1.0986. Well, this is just 4 minus 1.0986, which is 2.9014. Okay, we'll talk more about natural logs a little bit later, but now there's just one last one. This is along with this. So remember what you did when you had powers raised to powers, when you had exponents raised to other exponents. What'd you do with those exponents? Multiply it. So there's going to be some sort of multiplication. So here it is. Here's the product prop, or no, the power prop. Power prop of logs says this. Log base b of a to the n. They said p, I guess, for power, is just p times log base b of a. So all you're doing here is you're taking this exponent and you're putting it out in front. That's it. Okay, so basically 2 more examples, then we're done. So simplify log base 3 of 81 squared. Okay, what do you do with that exponent?
Multiply.
Yeah, you just put it over there. So this becomes 2 times log base 3 of 81. What's log base 3 of 81? Not 3. So 3 to the 3rd power is 27. So one more 3. So this is 2 times 4, which is 8. I love that because this looks confusing as crap, but the answer is just 8. It's exciting. Okay, what about this? What's natural log of 5e over x all squared? Okay, well, let's apply the power rule. Power rule says this guy goes out in front. So 2 times natural log of 5e over x. Well, let's deal with this next. This is another operation. How do you deal with a quotient? Well, then it's just 2 times natural log of 5e minus natural log of x, right? So far, so good. Okay, but that's all multiplied by 2, so don't forget that. Okay, but look at this. That's a product. So then this is 2 times natural log of 5 plus natural log of e, which natural log of e is just 1 minus natural log of x. Okay, so when you distribute all that out, you get 2 times natural log of 5 plus 2 times 1 is 2 minus 2 times natural log of x.
Wow.
Okay, that's crazy.
Yes.
But that's as complicated as it's gonna get. So make sure you look at that example one more time.
Okay.
Thank
All right,
you.
see ya. Yep.